Okay. So I'm going to do central tendency. Yeah, you need your calculator. Please take out your calculator. Okay? And if you don't have a calculator, take out your phone and please open to the calculator function. Okay? All right. Let's start looking at number 1. People seem to not even understand how to find mean. Okay? So there were some people that didn't actually understand mean. Let's make sure you understand how to find mean. Mean is you add up all of the numbers and divide by how many numbers there are. How many numbers are there? 1, 2, 3, 4. There's 12 numbers. Okay? So will you please go ahead and add each number into your calculator? Okay? Go. 184. Okay? If you add all of these numbers together, number 1, you get 184. If you divide that number by 12, you get 15.3. That is the mean. Does everyone understand how to get mean? Okay? We did 184 divided by 12, and we got 15.3. All right. Many people struggled with exactly what the median is. The median is the middle. Okay? There's 12 numbers. If there's 12 numbers, where's the middle? The middle is in between 6th and 7th number. 1, 2, 3, 4, 5, 6. Here's the 6th, here's the 7th number. I want you to actually mark this on your paper. Okay? This is the median.
8.5.
8.5. Okay? 8.5. It's also Q2. Median and Q2 are the middle. Okay? So, there's another way to do this. You could, if you wanted to, take 8 plus 9, you get 17, right? Divided by 2, and that will also give you 8.5. That's another way to find the median, okay? Is everyone okay with the median? I need a big fat nod there. Please say, convince me you know what I'm talking about, okay? Now, when you're finding Q1, Q2, and Q3, you have to start with Q2, okay? The median is 8.5. We're going to come back to Q1, Q2, and Q3. The mode, a lot of people didn't know what mode means. Mode, most, mode, most. The number that occurs the most. What is the number that occurs the most? 6. And then I was surprised with the number of people who didn't even know what range means. The range of the numbers, all you do, it's from the smallest to the highest. You take the highest number and subtract the smallest number. So you take 97 minus 1 in this case, right? 97 minus 1 is 96. That's the range. Is everyone okay with the range? Good? All right. Now, the minimum is the lowest number. What's the lowest number? 1. Okay? Now, Q2 we already found. Q2 is 8.5. To find Q1, all we have to do is take the numbers to the left of the median. All right? Just this section. Where's the middle of this section? There's 6 numbers. Where's the halfway point? Put this mark on your paper, please. Right here. Here's Q1. All right? Between 4 and 6. What is in between 4 and 6? 5. Okay? That is Q1. Does everyone understand how we found Q1? Okay? We do Q3 the same way as Q1, but it's on the right side of the median. Here's the right side. On the right side, here's 1, 2, 3. Here's the middle, right? Right here is Q3, right? If it's in between 12 and 13, what's Q3? 12.5. Does everyone understand how I got 12.5 for Q3? Can I have a big nod? We good? Okay. The maximum is, of course, 97. Now, would you agree that if I took the first 11 numbers, the first 11 numbers are 1, 2, 4, 6, 6, 8, 9, 11, 12, 13, 15. If I said forget about 97 for a minute, right? Would you agree that 184 minus 97, what's 184 minus 97? 184 minus 97 is 87. Does it make sense? If I added the first 11 numbers together, I would get 87. Everyone okay with that? Yeah. If I took 87, if I wanted the mean of the first 11 numbers, not including this one, the mean of the first 11 numbers would be 87 divided by 11. If you did 87 divided by 11, you would get 7.9, right? That would be the mean, okay? But with this number added in, the mean is 15.3. Would you agree that that number is significantly far different than this number, right? So in the question in number 1 that says, does mean or median best describe the data, all right? Without this 97, does it make sense that the median of 8.5 better represents these numbers than 15.3? 15.3 is higher than this highest number besides the 97, right? Does that make sense as to represent the average of the numbers? No, right? So what is a better description of the data? The mean or the median in this case? The median. Does it make sense why the median more closely represents these numbers? Right? Do you understand what I'm saying? Like let's say, for example, let's use these numbers like salary, right? Let's say people made 1,000 or 2,000 or 4,000 or 6,000 or 8,000 or 15,000, but there's one person who makes 97,000, right? If you were going to work at this company, would it make sense that right off the bat you'd be making 15,000? Probably not. right off the bat, maybe you could make 8,000 after a couple of years, right? But certainly not 15,000, right? The point is that this median is a better descriptor of the numbers rather than this number. I need a big fat nod. Do you understand what I'm talking about? Why is the median a better descriptor? What would you say? Why can't we use 15.3? Why can't we use the mean? Why is this number so high? So weird.
Because the road is also 97.
Because this 97 throws off the mean, doesn't it? Nod your head if you understand what I'm saying, please. I need you to make it clear that 97 throws off the mean. Does that make sense? Do you see what I need to know if you understand what I'm talking about? 97 throws off the mean. That's why we use the median for here. Okay? Look at number 2, please. Can we do the same thing? Could you add again, we have 12 numbers. What's the highest number here in number 2?
24.
24, right? Now the numbers are closer together, right? Could you add these numbers, please? $162. And when you take 162 and you divide by 12, you get what?
13.5.
$13.5. Did everyone get that? Can you confirm that you got that? I wanted everyone to add these numbers together. Confirm that you got 13.5 for your meeting. You got 13.5? Okay. Everyone understands how to get that number?
Yes.
I forgot an important part of this problem.
Oh, you forgot the scatter plot.
I forgot the box and whisker plot. Okay? That's okay. Box and whisker plot simply works like this. You put a big fat dot on 1. Right? What's the minimum? 1. So you put a dot on 1. Now, did I necessarily place 1 perfectly? No. Does it need to be perfect? No. Okay? Next, the first part of the box is Q1. Put a line on 5. That's right about there. Okay? Put your next line on the median is 8.5. 8.5 is right about there. And then Q3 is 12.5. Right about there. Close up your box. And make your whisker here. And where is
97.
97? Way out here, right?
Oh, you're supposed to put it above it.
It's fine. You can put it on the number line or above it. Either way, I don't mind. Okay? You can put it right on the line. That is your box and whisker plot. Okay? Okay. Back over here. The median is the middle number. How do we find the middle number? Well, there's 12 numbers. So we go in between the 6 and the 7. 1, 2, 3, 4, 5, 6. Here's the 6th and the 7th numbers. Now, because this number is 12 and this number is 12, does that make the median 12.5?
No.
No, the median is simply 12. Okay? So the median is 12. It's also Q2, right? Median is 12. What is the mode? The number that occurs the most. The mode is 12. What is the range? How do we find the range?
19.
24 minus 5, 19. Okay. What's the minimum? Minimum 5. What's Q1? Once again, here are the 6 numbers to the left of the median, right? So what's in the middle? 1, 2, 3. Right here is Q1. In between 8 and 9, Michael said 8.5. Okay, that's Q1. We already found Q2, that was the median. That was 12. Q3, we have 6 numbers over here. 1, 2, 3. Now, okay, how did you do that?
You add them together and balance.
All right. Darian correctly says we're going to take 18 plus 21, add them together, hit equals, and divide by 2. When you do that, you will get 19.5. There's another way if you like. What's the difference from 18 to 21? That's a difference of 3, right? From 18 plus 3 is 21. What's half of 3? Isn't half of 3 1.5, right? So what's 18 plus 1.5? 19.5. Or 21 minus 1.5? 19.5. That is your Q3. Okay? 19.5. What's the max? 24. Okay? Now, what is the best indicator or the best descriptor of this data? Is it median or mean? All right? When if the numbers are closer together, the best descriptor of average is what? Median or mean? Come on. Mean. Yes, Yasin. All right? If you want to find average, mean is always the best. Always. Unless you have some number way out in left field. Right? If the numbers are relatively close together, if I wanted to know the average age of the students in this class, and I added together the students in this class, I would find the mean. I would add the numbers together and divide by 10, because there are 10 students in this class. But if we added my age in there, that would not make sense. Right? The mean wouldn't make sense. Because my age would increase the mean well over the actual mean of just the students. Okay? So, who can give me a good answer as to why we use mean in this case? What is a good way to say it? Why is mean the better descriptor of this set of data for average?
Because the numbers are close.
Because the numbers are close.
I think it's us.
Just say it that way, okay? Because the numbers are closer together. Okay? Now let's do a box and whisker plot. What's your minimum? 5. Put a big fat dot on 5. Okay? What's your Q1? 8.5. Put a line there. 8.5. Q2 is 12. Put a line on 12. Q3 is 19.5. Put a line on 19.5. Your max is 24. Put a dot on 24. Close your box.
Put the lines on.
Put the whiskers. And that's your box and whisker plot, okay? That is how you do all of the measures of central tendency, okay? Does that make sense now? Does that make sense? Are we good? Okay. So, this one problem definitely takes some time, okay? Which is why I only gave you 8. I did 2 of them with you, so you only have to do 6, okay? So please do the other 6, all right?
This won't work.
I want you to start it now. You could finish it right now if you start it, okay? All right?
That's why you go. No.
Thank you very much.
Oh, yeah.